Hello, everybody. Thank you for joining us today at the first AccuWeather Climate Impact Program event of 2023. My name is Tyler Knowlton. I'm the Director of Communications, Communities, and Partnerships at Plume Labs, AccuWeather Center for Machine Learning and Environmental Data. The goal of the Climate Impact Program is to bring together experts across sectors and communities to tackle specific challenges related to extreme weather and climate action failure. We've been working with our partners at the Western Fire Chiefs Association for the last several months to explore the potential of pooling our expertise from the atmospheric data sciences of AccuWeather and Plume Labs to the unparalleled firsthand fire experience and knowledge of the WFCA. We're here today, thanks to our streaming partners at Brand Live, to look at what happened last year, talk about what we can expect in the coming months, and to zoom in from that view to a specific technical case study of the 2022 mosquito fire. And we'll be using a proof of concept smoke and fire map that we co-developed as part of this collaboration. Today's session is being recorded and it will be shared in a follow-up email after the event. Our expert presenters today are Chief Brian Fennessy of the Orange County Fire Authority. And in this role, Chief Fennessy leads more than 1,700 firefighters and non-sworn personnel who collectively serve 2 million residents across 23 cities and unincorporated areas. He holds a list of positions and laurels far too long for review today. I do encourage you to check out his full bio on the event page. You don't have to take my word for it, because in 2022, Chief Fennessy was recognized as Cal Chief's Fire Chief of the Year. Dr. Boris Quennehen, atmospheric scientist at Plume Labs, leads a broad range of our scientific activities, focusing notably on spatial modeling of air pollution, UV forecasting, and the coordination of R&D and research efforts. But before joining our team, his research really focused on the long-range transport of pollution measured in the Arctic and its impact on climate change. Paul Pastelok, Senior Meteorologist at AccuWeather, is a leading US long-range forecaster and has been with the company for just over 30 years. He heads up a team that provides clients with forecasts ranging from short-term to as far out as 12 months. His team has expanded globally and now provides long-range forecasts for Europe, Canada, South America, and Asia. Finally, I'd like to introduce you to our moderator, Chief Bob Horton, Chair of Oregon Governor's Fire Service Policy Council and WFCA Interim Deputy Director. Chief Horton has worked in public safety for over 22 years, a third of that time in an executive leadership role, but most recently, he was the CEO Fire Chief for a special district in Southern Oregon, serving a population of 54,000 residents. He's also a scholar practitioner, conducting applied research at the intersection of behavioral economics, public policy, and community risk management. And if you want to hear more from Chief Horton on a regular basis, he also happens to be the host of the popular podcast, Assuming Command, where he interviews thought leaders, innovators, and influencers in public service. And with that, I'd like to hand it over to Chief Horton to start things off.
Well, thank you, Tyler, for that great introduction. The Western Fire Chiefs Association is proud to be a partner with these agencies on the Climate Impact Program. We are really excited about what we see as a game-changing collaboration about these various experts of the different components that make wildfire, smoke, the environment so complex. But you don't have to take my word for it. Let's hear presentations from the experts we brought today. So without further ado, I'd like to turn it over to Paul.
Thanks, Bob. Today's presentation of the 2023 wildfire season created by my AccuWeather long-range team, and it's a little early, but we know that wildfire season is changing, and so we have to change as well, and looking at things a lot earlier than normal. So let's take a look today at what we're going to talk about. First of all, we're going to get into the summary of the 2022 wildfire season, look at some of the trends, some of the climate trends that have been taking place as well, and then a preview of the wildfire 2023 season. And I stress that this is a preview. There'll be more updates to come down the road during the course of the year here from AccuWeather. So let's look at last year, and we were in what we call a La Nina, a third year of La Nina, meaning that the northern jet stream much stronger to the north, affecting generally this time, in general terms, the northwest and western Canada a lot harder than farther south. And we saw a little difference this year because the La Nina was weakening as we went through the course of this winter season, and we start to see more heavy rain and snow making it farther south into California. Now, fires broke out early in 2022. In fact, late winter in the Southwest. They increased into the Northwest by midsummer. In Alaska, biggest fire season, seventh biggest fire season. A lot of the fires were tundra fires. They were let go, but they stayed away from a lot of the major towns. And that was good news. But they did inflate. The numbers did inflate the overall U.S. totals for last year. The Northwest heat and dryness, I think that was a big factor returning in the midsummer. We saw the Northern Rockies, the southern parts of Canada, all seeing fires that extended into the middle of the fall season until the wet season started to kick back in. In California, we did have a couple large fires, but it was kind of underachieved compared to recent years. And so we didn't see a lot of significant fires develop, a lot of it due because of certain triggers, which we'll get into the forecast here today. So breakdown more specific, I'm going to focus a little more on the factors. Okay, so you look at the Southwest, low previous winter snowpack. That's a big contributor. This year, a little different. Western areas of the Southwest have been doing very well. So that could be a difference maker going into this fire season. We had extreme drought, and we still have parts of the area in extreme drought, although the monsoons over the last couple of years in the midsummer have helped out. And with this La Nina pattern we talked about, it created storms passing to the north that kicked up a lot of wind. There's one of your trigger mechanisms for spreading of fires. So we had a lot of windy systems come by and extreme high temperatures early on in the season, especially in March and April, where high temperatures were way above normal in the Southwest. Moving on to Alaska, it was hot and dry early in the summer there, and the season extended pretty long. And so we had many fires that were burning for a long duration of time. And a lot of times they just let those fires burn out. So those acreage numbers just continue to pile up. And then you look at the Northwest, again, a warm, dry period east of the Cascades, mainly east of the Cascades is where we were focused on here. And the wet season east of the Cascades was delayed, so the fire season kept going longer. In California, we didn't see the numbers like we saw in 2021, 2.5 million acres burned, and well below 4.3 million in 2020. But we did have a brief period in the spring where fires ignited, then they got contained, and then early September, the mosquito fire and a couple other fires started to come out of control. But again, the season down from previous years. So factors that impacted California during 2022. Well, the previous wet season started really good. In fall of 2021, we had lots of rain, lots of snow coming in. Everybody was talking, this is looking great, this is positive. And then all of a sudden, the spigot was turned off in January and February. It dried out. We lost a lot of our water, a lot of our snowpack, and then a little bit of a rise in late spring, but it wasn't enough to recap. So in the early part of the season, we're all saying, this is not looking good. This is not looking good for California. We're going to have to watch for more things to happen. Higher elevations, yeah, they were, had wetter fuels, stayed longer. We didn't expect the higher elevations to start off early, and that's what happened. And then the long-term drought conditions were still pretty bad. Even despite the fall season, that dry out period in January and February was not good. And then as we went later into the season, we started to see some timely rain events take place in late summer and early fall. And the biggest thing that you look for this, it seems like lately, is trigger mechanisms. We had a lack of that in California last year. We didn't have as much lightning, and we had less wind, less Santa Ana winds, less Diablo winds. That usually helps with the spreading of fires and the triggering of fires. A lack of that may have been one of the reasons why we saw lower numbers last year. But we did also get some tropical moisture from a system, and also a big system early in the wet season across that area. And I threw in this last comment about COVID restrictions. Remember, we lifted the COVID restrictions last year. So a lot of people during COVID were going to the hills, going to the mountains, going camping. And over 85% of most fires start in the West are started by people, humans. And so with less people maybe going out in there and going to other places for vacationing, we may have cut down the risk possibility there last year. Now that's kind of reaching a little bit, but it's just one thing that we noticed in the numbers. specifically the mosquito fire. Now, you're going to get a lot more discussion on this later on, but a couple of things, conditions that were watched then that we're going to watch this year as well. The heat wave leading up to the start of the fire was pretty significant. We're not anticipating that much heat this year because of the wetness and soil early on, so that's a good thing for us this year. Terrain made it very difficult. Truck and plane, any way to get up there was very tough to fight this fire. Thunderstorm development, that also causes what we call wind fanning, and that wind fanning created more spread of the fire, made it tougher for the crews to fight it. And in addition, we saw a fire vortex form, and what that does is lift a lot of that debris, burning material, lift it up in the sky and spread out and cause more fires to develop off of that. So we saw something like that. But then we looked at the moisture. Now, Kay was a hurricane in the Eastern Pacific. The remnants came all the way up, but it was kind of more of a negative than a positive. It created more wind than anything else where the fires were burning, and that was a bad thing, more spreading of the fire, of the mosquito fire. Then around mid-September, we started to see more systems actually coming in out of the season, late September into early fall. And that created, more beneficial rain. Still produced some wind, but it did help out. And the one thing out of all this, when I look back at last year, is us as forecasters, if we can predict these probabilities ahead of time of tropical systems, of when the wet season is going to begin, when the southwest monsoon is going to start, and that's what we try to do at AccuWeather. If we can predict those, I think we can give more help to everybody else in the Western chapter. So this is something that we continue to work on and research throughout the season. Now, looking back at percentages of precipitation, that's very important. Soil moisture, we like to look at that very carefully. What we did notice going into last year's fire season, the previous winter wet season, we saw an abundance of snow in the Cascades on north and west. So we had a good feeling that that area may be limited on how much wildfire could go on if it didn't get hot and dry, and could start later as well. But the two other areas that are highlighted there were a little bit less on the precipitation side, a little less on the snow side. And then we kind of saw a red flag there on both sides. And we knew that what happened in the Southwest, New Mexico really took off on the fires last year. And also, where were the fires in California focused mostly? Across north central California. So this is a good tool to use when we can. Then looked at rainfall and broke it up a little bit. And I wish I should have had a fourth one here just to show you what's happened recently. But early in the year last year, when that dry weather came in, that pattern in January and February, the whole Southwest dried out. We're back into that extreme drought situation again. And then the monsoon came in mid-June, earlier, 2 years in a row, early monsoon arrival. Good news there, dousing a lot of the fires in the Southwest, but not getting back far enough into California, not just yet. And then we saw the second one on the 36-month you see on the right side. Again, just showing you that over 36 months, we've seen good moisture in Arizona, western New Mexico, and now, after this year, we're seeing in northern Arizona, southern Utah. In fact, Flagstaff has over 60 inches of snow for the season already, and that's good news. This is moistening up those soils, which will take a little more time instead of an early start to the fire season in western areas of the Southwest, but still a little risky, you can see, in eastern areas where they haven't got much of that precipitation yet. And then looking at the trends of wildfires, the things that we've been noticing over the last 15, 20 years is that wildfire acreage has increased. Bigger fires in the West creating this activity, but the number of fires has slightly come down. Now, I don't have a really good reasoning for that, but one thing that I've noticed is that maybe the number of, remember this is a U.S. total, maybe the number of fires in the eastern half of the nation with wetter conditions, wetter patterns, has brought down the numbers. Not so much the West, but the East on those totals. I have to do more research on that, but at this point, that's all the evidence I can give on why the numbers have come down. But the acreage, for a lot of reasons, like the multi-decadal drought that we've been seeing in the Southwest, have contributed to these long, big fires. And speaking of long, the wildfire season itself extending. This map shows you how the change in fire weather days has changed during that climate period that's indicated on the graphic right now. And look at California. The expansion longer the season, of course you're going to get more acreage, of course you're going to get more fires, and that extends, everything is affected, air quality, you name it. So we're seeing again the expansion of wildfire season, and which is another reason why we're speaking this early today. And then look at the top 20 largest California fires. Look what period they occurred in. Over the 2020, 2021, over half of that total occurred in those years. And then you go to 2000, almost 75% of that total occurred since 2000. So some really big fires over the recent years created in these numbers. And then just looking at the last 5 years here in California, we talked about 2021 and 2020 being big years as far as the amount of acreage being burned and the amount of fires, big fires. But there was some breaks. There are some breaks. But I kind of put a cross over 2018. And the reason why I did that is that when we forecast in the long range, we look at just not forecast long range models, but we look at other years that kind of match up to the current year, and then look back at that year to see what the trends and other things like rainfall, heat, and fires, and what it did in those years. And we try to come up with a forecast related to that. And we find other years as well, match them up. And we look at 2018, one of my top analogs going into the spring. And look what happened in 2018. Most of the fires concentrated across Northern California. So that's an area we're going to be watching very carefully to see if we're going to see, no year ever works exactly the same way, but it can give us an idea of where and when the seasons start as far as the wildfire seasons go. And just again, showing another graphic here of California showing that trend. I'm not a very big fan of 5-year averages when it comes to wildfire. I like the longer term averages. But again, you can see there's been a rise in recent past over the last 10, 15 years, kind of just paralleling the U.S. totals as well. So looking at this wet season so far, again, I'm only out to January 10th, but in any case, I think it covers most of what's been happening. You can see in that circled area, very moist conditions, very wet season so far, a 4-week period here in late December, early January, the reasoning why we're seeing this. So, and you don't want too much at the same time you do. And here's the thing, this is the fight that we us forecasters are. You're going to have a lot of moisture, a lot of soil moisture, probably delaying the fire season in Central California and a lot of places in the interior Southwest. But you're going to have a lot of growth. And when those fuels start to dry out, and if they dry out rapidly this summer, then we could have, again, larger fires to deal with. So that's the pull that we look at here early in the season. And then we look at the other trigger mechanisms as we get later into the season. And you can notice the Southwest, it doesn't have the coverage of what just happened. This is a little bit little early on this map, but you can see that there was some moisture in Arizona, but it really increased over the last week and a half. So the factors going into 2023, again, this first factor is mostly for the eastern areas, chance for drier than normal in the interior, far interior Southwest and lower snowpack. We already know what's been happening over the last week or so in the far western areas, and it's growing, and that's good news. That will hold back probably the fire season from starting too early. I think you can determine a lot of times in the Southwest based on some of this knowledge of percentage of precipitation and snowfall. The strength of the upper high pressure area in the plains in June and July. This is a typical thing that happens. It's like a seasonal change that could take place. If that happens, it increases the monsoon and it starts either early or on time. We do see this high coming in our forecast models for June and July. So the monsoon will at least come on time. Not sure if it'll get there early based on the change of La Nina to El Nino. That also has a negative effect on early monsoon. Why do I bring all this up? Because it does have an effect on the Southwest fire season. Once the monsoon kicks in, then the fire season really goes down pretty quick. And again, El Nino's, when we go, we're anticipating an El Nino later this year. And what that means is the southern track starts to take over, and we can get busier in the Eastern Pacific as far as tropical seasons go. So some of that moisture can get lifted up northward and start the season sometimes early or late, but we've noticed a tendency for El Ninos to actually start the season late. So there's a tug of war going on with this change from La Nina, El Nino. And really, the El Nino doesn't really have a full effect until we get into the fall and winter this year, we feel. So it could be a late starter. And so we have to really look at all this stuff in the spring and get it together to figure out exactly when things are going to start to come together and when things are going to end as far as the season goes. Pockets of dry weather. back and forth from northwest. That will probably control the fire season going forward. But those pockets, if they start getting really long on the drier side, middle of summer, then things are going to start getting going. In California, again, one of the most intense wet seasons that we've seen in a while, at least put together for the entire wet season. And we do expect it to continue a little off and on here in February. And then again, maybe some unusual activity in May that could continue to hold back some areas from going crazy as far as wildfire development. But at the same time, as you get later into the summer, if we see any of these out of control or unusual kind of systems popping up, they could be more trigger mechanisms than beneficial. So that's something we're going to be watching as well in our forecast going forward. As far as precipitation from the models, I got a couple graphics here left. The American model, one of the American models that we look at, the CFS on the left, is a spring. It's actually a 3-month graphic. You can see 6 graphics there, 3 months at a time. The MAM means spring of 2023. The JJA means summer of 2003. And you can see this is old. This is about 2 weeks old, but you can see that it's forecasting drier than normal conditions through the spring and summer in Northern California, Northwest. Again, a red flag there to watch. If these fuels dry out too quickly, we may have some bigger fires after a pretty decent start to the wet season in these places. Our analogs combined that we talked about earlier in the presentation show drier than normal spring, but not so much in the summer. And the interesting thing is the new American model that just came out on the left is showing a trend towards normal precip. Now, I know in the summer, normals are very low, but that could be an indication of this unusual activity I was talking about that could pop up and cause a trigger mechanism for fires to develop. So I'm not saying that's going to happen 100% right now, but it's a good thing to watch this early in the season that we could start to see more help for fires being started across northern central California into the northwest, maybe a little later the farther south you go into California because of all the moisture. And we took those analog years, we take them, like I said, and we look at the number of fires for the US and the number of fires in California, and we kind of try to do all the research in these years. And here we take a kind of a combination of 2018 and 2012, and we come up with these very preliminary totals. Now, it's a big range, I understand, and you're looking at it, but we're going to shorten that range as the season goes on with more updates, okay? Because we have to see more things develop before we can go definite. But these are just preliminary totals on the right for the US and for California, much higher than last year, but still not getting quite up to 2018 territory or 2020-21 territory. So that's what we're looking at for as far as totals go. And to sum it all up, the Southwest fires, I'd like to start early again, but not as early as last year. Started in February last year. We're probably looking more like late spring this year. Western areas probably even later. Eastern areas a little bit earlier. The Hawaii, that should be actually Alaska. I apologize. It should be Alaska wildfire count. 2020 was exaggerated on the numbers, but we do expect an above normal season this year, but not as bad as last year. Increasing growth in the Northwest, late spring and early summer. I mean, that's going to turn the fuels drier, and that's what we're going to be concentrating on Northern California and Northwest. And as far as California go, like I said, we took between 2018 and 2012 year, looked at some of the totals and took kind of an average leaning towards 2012 because that year is working out very well here in the winter season. Season may get a little busy until later in the summer, northern areas. Again, after the period of mid-drying takes place, the soil moisture is going to be very critical, I think, in California to where it's going to get going. The higher elevations may take a while, still with snowpack developing. And then, again, the significant growth should dry out later on. And SoCal, the question mark there is, will we have more wind events, more lightning events compared to 2022? That's what we're going to be watching very carefully with the El Nino, the trigger of more tropical systems in the Eastern Pacific. If we get any of that heading northward, those could be trigger mechanisms for the season heading for, in the larger distance. So, and that's it. That's all I have for today. I'm going to pass it now over to Bob.
Thank you, Paul. That was a great presentation, and you do a wonderful job of taking these complex variables that all impact what the fire weather situation looks like and distill it down to something understandable and very useful data, not just for fire service professionals to prepare for the upcoming fire season, but for our communities and the folks within our communities as well. Let's turn it over right now to Chief Brian Fennessy of the Orange County Fire Authority to give us his take and experience on the 22 fire season. We'll do a zoom in also specifically on the mosquito fire. Chief Fennessy.
All right, thank you very much. And I too, along with Chief Horton, really appreciate everything you shared, Paul. We in the fire service throughout the West, we rely on you and your team, for this type of information. And some of it is validation of what we've experienced on the ground. Very much so in this case. I particularly appreciated the piece about Alaska and how that contributed to the overall acres burned nationally. Being situated here in California, you're absolutely right. We expected the worst, and due to enough tropical flow and actually some midsummer rains, we experienced which in the past would have been considered maybe an extreme fire season, but at 360,000 acres, really not nearly as bad as the previous 2 years where we were over 4 million and then 2.5 the year before. So big shout out and thanks to you, Paul, for all you and your team do. And I know we're going to talk a little bit about smoke, or Dr. Quennehen's going to talk about smoke in a bit, but I recall I've got a lot of friends in Canada, and how bad they were impacted by the smoke in Canada from those fires in Alaska. So that was really extreme. I would. Why don't we go right to the presentation? All right. I will. Let's see here if we can advance. Oh, there it is. All right. I want to talk to you a little bit about the 22 fire season from an operations perspective. We all know that the risk of catastrophic fires has increased. We've seen that, and Paul's presentation certainly demonstrates that. I've been in the fire service since 1978 and spent a lot of time on hotshot crews before I went to work for the city of San Diego and then ultimately Orange County. And I recall, fire seasons back in the 70s and 80s that if you had a 20,000, 30, 40, 50,000 acre fire, that was a career fire. Those were significant events. They weren't millions and millions of acres like we're seeing now, post 2000. When I say there aren't enough resources to adequately suppress fires, I generally mean when we have multiple fires burning. That is true. I mean, even when we don't, we could always use more resources, more aircraft, more bulldozers, hand crews, engines, you name it. I think one of the things that we really got lucky this year throughout the West is that we didn't have multiple fires burning, throughout the West. And that's when we start to really see resource drawdown. We were able to send in California, the West, resources to Alaska during a period of time that historically would have been very difficult for the Western United States. The tropical flow really was balanced with, not having that extreme wind. We talk a lot, the fire service about having adaptive and resilient communities. And that's not just, having communities prepare defensible space and take care of it, have all the things that we profess that they do. But they need to have real-time actionable information. And for those that aren't aware, the Western Fire Chiefs Association built a fire map. It's called, it's just that, it's called Fire Maps. And, they've partnered with AccuWeather and their Plume Labs to build, a demonstration of this capability. It just goes to show that when you bring the best of weather, fire, and smoke experts, you can have something. I encourage my communities and throughout the state, anybody I talk to have that link readily available, especially if you're in a community that's vulnerable. if you are evacuated, of course, if you ask the evacuees, what do they want to know? They want to know, how their home is. Has it survived? Those sorts of, they now have the ability on their handheld device to be able to go to fire maps and actually see where that fire is. Where is the perimeter? Where are the aircraft working? We have intelligence gathering aircraft that are embedding videos. Nothing relieves somebody that's been evacuated more than to know where that fire is. It's the unknown that really is, the scariest part. And I'll share a little bit in my last slide a video of some of the intelligence gathering information that is available to the public. We're going to talk a little bit about the mosquito fire. Mosquito fire began in the evening on September 6th of 2022 in the northern Sierra, Placer, El Dorado County, Tahoe National Forest. This was a fire that, the conditions were, 110 degrees plus. We've been experiencing a heat wave for multiple days. With that heat comes low humidities. We're talking down in the teens. And, this warning of unstable air, which can cause plume domination. I'll talk a little bit about that. But it started in an area that was very difficult to access down by, I believe it was Oxbow Reservoir. And very difficult to get to by ground resources, very steep country where many times you have to wait until the fire, gets up on the ridge lines before you can really engage it. And again, this following many, many years of drought conditions, a lot of dead, standing timber and other vegetation. So a very, very bad location for a fire. So I want to talk a little bit about this plume domination. It's a phenomenon that we see, and many times the public will recognize it, where we have a fire that is releasing so much energy. It's really great enough to overpower the environment. Plume domination is somewhat rare, but it was a factor here in mosquito fire early in the first several days. These are those plumes that you see grow very quickly, where the tops are at potentially 30,000 feet. They look like a thunderstorm. They're called pyrocumulus clouds. And one of the major hazards that we have as firefighters on the ground when you have one of these plumes is that when it collapses. Could it collapse? If you can imagine all that energy, very tall in the sky, lots of heat, sending large firebrands way out in advance of the perimeter. When that comes crashing down and you're on the ground and you're nearby, it can be chaos. The weather changes very quickly. The wind blows in all directions, and the fire behavior can change, and usually does change very quickly. It's something that we look out for. It's something that people like Paul and others alert us to in the mornings at our firefighter briefings. But this was a factor early in the mosquito fire. In fact, if you look at the data, the fire practically doubled every day until the weather changed. It became more favorable for the firefighters. I'm sharing with you a map that the date is September 11th. You can tell 41,700 acres in just, from September 6th to September 11th. That's significant growth. And again, we had fires throughout the West, certainly in California, but this was the priority fire in the country. It was receiving the resources that it requested more than any other. So there was not a tremendous amount of competition for resources. But you look at the 3 days of growth, again, some of that had to do with some of the plume domination that they experienced, the pyrocumulus clouds, but also, probably more significantly, is the dry fuels and the topography and the inaccessibility of this fire. But you can see by the colors the different levels of spread. Again, I know Dr. Quennehen's going to talk a little bit about smoke here in a bit, but if you look at the left, look where that smoke is going. And, in doing research and looking back on this fire, certainly the smoke conditions, around the fire, and certainly in the path of the fire, where you can see the plume, it was bad. But what was especially bad and extremely unhealthy was the Tahoe Basin. That smoke just sat in there, and it clogged up that basin, and the unhealthy readings they were getting there were tremendous. That smoke will carry all the way across the country. On the right, again, you're seeing a spread model of the days of fire that it was spreading out to the east and northeast. Very steep country. And again, all of this, if you look on fire maps, when you have a fire or any fire, you're going to be able to see in 3D the terrain like you're seeing it here. So with that, why don't I go to the video? And this video is one of two. It's called the FIRIS, F-I-R-I-S, the Fire Integrated Real-Time Intelligence System. It's two aircraft equipped with multiple sensors. The idea being giving the folks on the ground real-time information, both via video, perimeter maps, a variety of other ways of seeing that fire in ways that they can't see that. When I go to the video, you'll see the fire. Understand that it's an infrared view. Smoke was occluding a view of this fire. If it were in color, you wouldn't be able to see anything. So infrared gives us a very good idea and visual display of where that fire is. So I'll go right to the video now.
This is the mosquito incident on the Tahoe National Forest, Oxbow Reservoir in the crosshairs, 822 acres. There's dozers working above the head. It is in the confluence of the Middle Fork and North Fork of the American River and Oxbow Reservoir. The closest structures we saw were about 1.5 miles to the west on the ridges. End of recording.
So you can see, how a picture like that on a handheld, whether you're an engine captain, you're the incident commander, wherever you may be, an air tanker pilot, is giving you situational awareness that you couldn't have any other way. Again, much of these videos are embedded in Western Fire Chiefs Association fire maps that's available. Use whatever search engine you have and look that up and keep that as a favorite. I'd encourage everybody. And, at this point, I will turn it over to Dr. Quennehen. Boris has a presentation on smoke. Smoke is a huge concern, certainly to the health of our firefighters, but absolutely the health of our community. So thank you very much for your time, Chief Horton, and appreciate this opportunity.
Thank you, Brian, and hello, everyone. So let's talk about wildfire smoke, and let's start by a quick definition of the smoke, which is an important and dramatic consequence of the wildfires. So smoke is a byproduct of the combustion of any fuel available at the wildfire location, and thus it's physical and to the nature. But to simplify a bit, let's say that smoke is composed of gases and particulate matter, and let's focus on the discussion on particulate matter, which is the most impacting pollutant for human health. So particulate matter are...
All right, we're having a little bit of a technical difficulty with Dr. Quennehen's connection. We're going to continue to work on that and if possible, maybe bring up his presentation and help share some of the valuable information that he has about smoke. But if I could for a minute just ask a question, if I get our team to bring up Paul for me for a minute with me. I really want to speak to what Chief Fennessy said in terms of resource allocation. There's a couple of things that we think about as fire professionals, and that's what are the environmental conditions that's going to contribute to the spread of wildfire, and what is the impact that our fire suppression efforts, be it folks on the ground or our aircraft on the wildfire, which ultimately is going to influence the next steps or where the fire goes. And Paul, thanks for coming in quickly. How valuable is the data sharing from the fire service in terms of what type of fire suppression effort and the impact that may have on the fire? How valuable is that information for you to forecast what's going to happen in the next hours or days?
It's very valuable. There's so much information there that helps us prepare to what our next step's going to be. Now, granted, our company, we have two divisions here. I am basically the longer range expert forecaster, and I look at things in advance by pattern recognition to give you guys heads up, not just a day in advance, but weeks in advance. And then we have another part of our company that works in the shorter detail, that has even more advanced knowledge on this information that you show on your sites that they use, most importantly, to put out their forecasts in the next 7 to 10 days. So again, what our company does is that we can provide from two sections a lot of information for you guys in the short term and in the long term based on that information that you give to us. And at the same time, we can transport it and give it to the public with our network and our team of AccuWeather writers at the same time. And so that's why working together with you, getting that information, giving it back to you, and then also sharing that information, we can also help you and the public at the same time.
Thank you, Paul. That is really important. It looks like we have Boris back, so let's bring him back up and see if we can't continue his part of the presentation.
Yeah, sorry. And yes, so the impact of the smoke on human health is dramatic, and it is amplified by the ability of the smoke to be transported on large distances and thus potentially impact a very large number of people. The meteorological context is the key driver of such a transport, and if the meteorological conditions are favorable, smoke can travel across continents. You can clearly see that on the left side of the slide, which shows satellite observation from MODIS over the US on the 16th of August in 2021, when a large part of the US was covered by smoke from western fires. Satellites are amazing tools to early detect and track wildfires and smoke, especially in remote areas, but it's not easy to derive the vertical location of the smoke from satellite observations, which means that from an operational perspective, we can't rely on satellite only to issue alerts to the public, for instance. And this is where the wildfire smoke dispersion forecast comes in. So the map on the right of the slide presents the smoke forecast from Norway on the same date, but at the ground level only, which is more convenient to estimate the impact on people. In addition, forecasts are obviously very useful to detect in advance potentially impacted areas and issuing alerts accordingly, and that makes it sound like a perfect solution. So one may ask why smoke forecasts are not more widely used and available. And unfortunately, it is because forecasting the wildfire smoke dispersion is a very complex task, because you first need to detect the location of the wildfires with human and or satellite observations. Then you need to forecast accurately the wildfire evolution based on the topography and the type of fuel at the ground level. And then you need to estimate the associated particulate matter atmospheric emissions in close relation with the fuel property. And finally, you need to disperse the generated smoke according to the weather conditions. And you need to master each step of this process, which is really cross-disciplinary and thus really complex to build. So now to illustrate more concretely how smoke may impact people, let's have a closer look at the mosquito fire. So on the slide, you can see a map with the location of the EPA monitoring stations installed in the vicinity of the fire, and which, among other pollutants, measure the particulate matter concentrations that would correspond to the wildfire smoke. You can also see the time series of the particulate particulate matter concentrations for the Sacramento and the Reno metropolitan areas. The red curves represent the EPA, the PM 2.5 average concentrations as measured by the EPA monitoring stations, isolated in the small rectangles. And the blue curves stand for the NOAA smoke forecast at the ground level. Please also note the black dashed lines at 50 and 100 AQI, which correspond respectively to the WHO recommendations for daily and hourly exposure. WHO stands for World Health Organization. The Sacramento and Reno metropolitan areas regroup almost 3 million inhabitants, which have been exposed to particulate matter concentrations way over the WHO recommendations during several days, which means that those 3 million inhabitants have breathed harmful level of particulate matter. We don't have access to medical data specifically related to this event, and so we are unable to quantify how people have been impacted by it, but based on the knowledge on the impact of particulate matter on human health, we can guess that such a wildfire had a significant impact on the health of a large group of people, and that underline even more the crucial mission of the firefighters and the need for strong and efficient alert systems and education on how to protect against smoke. So that's it for me. Thank you for listening, and I drop the mic to Bob.
Thank you very much, Dr. Quennehen. What a great presentation, and very much appreciate your insight. What's really important to understand about smoke is many of our folks who are listening here have probably experienced, even if the fire is hundreds to thousands of miles from you, there's an impact to you. So the data that's presented through this type of modeling is valuable for those communities not necessarily impacted by fire, but impacted by smoke, and can alert community leaders in environmental quality and public health on to take action on how to protect their community from the dangers that smoke would bring. Let's bring our panelists back in and share some final thoughts and reactions. Chief Fennessy, as a leader of the community, not just having to deal with the fire, but maybe impacts of smoke, could you just share your thoughts on this connection of data through a public-facing map, and how valuable you see that being by bringing the expertise from what we presented today, 3 different disciplines, bringing the best intelligence and data together in one space? How is that valuable to the community?
Well, in what I've experienced thus far, for those that have, pulled up the fire maps and have used it, the feedback has been tremendously positive. And you said it better than anybody, Chief. You may not be affected by that fire. Your home may not be a threat, but everybody is affected by that smoke downrange. Certainly people, that have health issues, but in our business, as you know, better than anybody else, the incidence of cancer have just increased tremendously from all the carcinogens. Well, these fires are passing those same carcinogens onto our communities and in great distances. So, there's certainly an economic impact. If you can't go to work, or if you can't filter that smoke. I'm told that many employers let their people stay at home or work from home, but there is an impact, and I think it's greater than what people realize. And so, to the degree that we can enlighten and encourage others to use, the maps, this Western Fire Chiefs Association fire maps in partnership with AccuWeather and the Plume Lab, I think we're off to a good start. We just need to, I think, really promote it strongly going into this fire season this year. Thanks, Chief.
You bet, Brian. Thank you very much. Boris, a question for you, because we focused in on the mosquito fire today in California as an example of how data and information and intelligence was useful from the map perspective. But as a smoke modeler, you have an additional challenge. You may be trying to estimate the impacts of smoke to a community or smoke spread of multiple fires, and the smoke kind of overlapping as they shuffle together in our skies. How difficult for you is it to be able to make those estimations when you're dealing with multiple fires on the landscape at one time?
Well, yeah, thank you for the question. And yeah, to be honest, we are not able to isolate the impact of a given fire. For the mosquito fire, it was pretty easy because no other fire was burning in the vicinity. But when the model is running, it simulates all the fires at the same time, and the smoke is modeled at the same time as well. So we are not able to isolate the smoke and to attribute it to a given fire. So I will say that the complexity is on the other way. It would be to attribute the smoke to a given fire instead of mixing everything.
Thank you. Thank you very much. I'd be remiss if I didn't call out Chief Fennessy for his use of a meteorological term describing the smoke clouds. I'm not going to ask Paul if he got it right. We're just going to assume that he did. And I know his expertise certainly brings that. I want to thank our panelists for taking time today to share their perspective on the 2022 fire season and some predictions ahead for what we can be planning for as communities and as leaders of our various disciplines. The part of the point of today's presentation was to demonstrate the power, the synergistic power of bringing an interdisciplinary approach, a collaborative of expertise from multiple disciplines that have an overlap on this complexity that wildfire brings. Weather forecast, fire experience, and smoke are increasing, as we heard from Paul's presentation, and frequency and intensity and severity. Longer fire seasons due to the climate impacts are putting strain to firefighters, frankly, who are used to working so many months in terms of the fire seasons that they're experiencing in the U.S. And now we've extended to oftentimes year-round fire seasons. So showcasing how we're able to bring this information together in a digestible and usable fashion, bringing the best intelligence that's available to us today, using the best experts to process that and make it digestible for our communities is what we were here to showcase. And Western Fire Chiefs Association is proud to be a partner of the Climate Impact Project. And thank you so much for having us today. Tyler, let me kick it back over to you.
Thank you, everyone. To our presenters, our experts, to our hosts at Brand Live, our streaming partners, and for all of you who joined us. I hope this was useful. This is the beginning. We've got some great collaborations ahead, and I'll remind everyone that this session was recorded, and we'll be sharing that recording in a follow-up email, and we'll be making it available live online. We'll also have a link to the map that was our proof of concept for you to be able to play around with it, zoom in, zoom out, adjust different factors and see how it all worked. And that's it for today. Thank you very much.